Hi, Math 20s. This is the last lesson of proportional reasoning. Alana's staring at me and is probably going to yell some stuff. She yelled math rules if you didn't hear it. So this is the last one. So we're going to look at just really related to what we had last time, but now looking in 3 dimensions. So we'll be talking about volume stuff. So what this has is just a Rubik's Cube. So it says find the measurements of both the Rubik's Cube, the whole thing, and the measurements of one of the small cubes that makes up the larger cube, given that the length of one small cube is 1.5 centimeters. So it's saying, look at the cube as a whole. Oh, this is delayed. Hopefully it doesn't do this the whole time. But then also look at one small cube. Oh, that's going to be irritating. So it's saying the length of one small cube is 1.5 centimeters. So when it's saying the word cube, that means that the length, the width, and the height are all going to be equal. So for the small cube, again, it told us 1.5 centimeters. And for the width, we know that it's going to be the same since it's talking about cubes, so 1.5 centimeters. And then for the whole cube, so we can see looking at kind of that red face, it's 3 of the little cubes, so 3 times 1.5 across, and then 3 times 1.5 up. So in total, the length of the whole cube is 4.5 centimeters. And the width of the whole cube is also 4.5 centimeters. So using your measurements above, determine the following. So we're going to look at the scale factor for length and scale factor for width. So what we need to kind of do is determine like which way we're comparing it. Are we comparing the small to the big or the big to the small? Because it'll give us 2 different ways to represent it. So what I'm actually going to do is make it the comparison of one small cube to the whole big cube. So our scale factor for our length, we could put it as 1.5 centimeters to 4.5 centimeters. Or again, usually we'll have that kind of reduced as to have one of them as 1. So the ratio we could use would be 1 to 3, which should make sense, right? There's one small, like if we're taking it, comparing the small to the big, it's 1 small block to 3 small blocks within the big. So our scale factor is equal to 3. And then the scale factor for the width, this is going to be just the same thing. So 1.5 to 4.5. And so we could use that ratio of 1 to 3 with the scale factor equal to 3. And so what do you notice about the scale factor? They are the same. So when the scale factors are the same, the shapes are called similar. So we talked about that in the angles and triangles unit, that if it's just scaled up or scaled down, we were talking about similar triangles. In this case, it's similar as well, as long as the scale factors are equal. So you can't increase the length of something by a scale factor of 2 and increase the width of something by a scale factor of 5. That's not going to give you the same shape. It's going to be kind of a warped shape. So it says determine the area of one side of the whole cube using only your scale factor and the original area. So this is kind of into the second part of yesterday's lesson, that we know our k squared, or our scale factor squared, is equal to the area of the similar 2D shape divided by the original shape. And so if we rearrange that formula, so the area of similar 2D shape is equal to your k squared, so your scale factor squared, multiplied by the area of the original shape. So if you have no idea where I got that formula, look back at that last lesson. It is just rearranged to solve for the area of the similar 2D shape. So our k squared again was 3, so 3 squared multiplied by the area of the original shape. So those little boxes, again, to find the area of something, it's length times width. So 1.5 times 1.5 centimeters, and so we get an area of 20.25 centimeters squared. So 3 squared is 9. If I multiply that by the product of 1.5 and 1.5, I get 20.25. And what we could actually do in this case, it says, again, the reason I did it this way, it says using only your scale factor and the original area. So the original area being the area of a small cube, our scale factor of k, gets us the area of one whole side of the big cube. But we can verify this as well. And the way that we can verify it is take the length of the whole cube and multiply it by the width of the whole cube. So we could do our 4.5 times 4.5 gets me 20.25 centimeters squared. But again, since it was asking us to only use our scale factor and the original area, we needed to do it that first way. So the next part, so coming into the 3D part, because again, area is just 2 dimensions, but now it's asking us the 3-dimensional part. So determining the volume. So the volume of one small cube is your length multiplied by your width multiplied by your height. Again, they are cubes, so all of those measurements are going to be the same. So the length was 1.5. Width is 1.5 and your height is 1.5. So if we do 1.5 to the power of 3, that gets us 3.375 centimeters cubed. So your units of volume are going to be centimeters cubed. So determine the volume of the whole cube. So again, length times width times height is now 4.5 times 4.5 times 4.5. So if you punched in 4.5 to the power of 3, we end up with 91.125 centimeters cubed. So the volume of a small cube multiplied or versus the volume of the whole cube, which is what it's actually saying in this next question. Oh, so what is the relationship between the volume of the whole cube, the volume of one small cube, and the scale factor? So it's kind of asking us how are these related? And so our new formula that we end up looking at is our scale factor cubed. So when we're talking about cubed, again, we're going to be talking about volume, so 3 measurements. So the volume of the similar 3D shape divided by the volume of the original shape, or original 3D shape. So just this question is really just looking for that formula, but I want to use our Rubik's Cube example to kind of show that piece of information. So if we're calling kind of our small cube the original and our big cube our similar one, we would take that 91.125 125, because that's the volume of our similar shape, and divide it by the volume of the original shape. So 3.375 centimeters cubed. And again, that's going to give us our K cubed. So when I divide that, it didn't actually do this. It should give me 27, but let's make sure. Yeah. So 27. So that gets us K cubed, or our scale factor cubed, equal to 27. So now if I wanted to find our scale factor, we need to cube root both sides. And so the cube root of 27 is equal to 3. And that was that scale factor that we got on that last page for how it's scaling up, right? The Rubik's Cube, if you compare a small cube to the big cube, it's increasing by a scale factor of 3. So hopefully that kind of makes sense. Again, this new formula you can use for solving for your scale factor eventually, for solving the comparison of the volumes if you have the scale factor. So it depends what you're actually looking for. And so this one, next one, it says, if a cube that has a volume of 20 centimeters cubed is to be enlarged by a scale factor of 1.8, then what would the volume of the enlarged cube be? So looking at that formula that we had just up above, so volume of similar 3D shape divided by the volume of the original. Of the original 3D shape. And so what it's asking us for is this portion of the formula. So I need to rearrange to solve for that. So in order to isolate the volume of the similar 3D shape, I know I need to multiply both sides by the volume of the original 3D shape. So now I would have K cubed multiplied by volume original is equal to the volume of the similar. Oops. So now we can substitute in. So the scale factor of K is 1.8. So it'd be 1.8 cubed multiplied by the volume of the original is 20 centimeters cubed. So 1.8 cubed multiplied by 20 gets me 116.64 centimeters cubed. So you can work on the textbook stuff, the questions from this. So there's going to be a lot of word problems, thinking about how you can apply that formula to solve for it and what sorts of information you can get out of it. If you need other volume formulas, they're on page 495 in the textbook. I believe I wrote that on my sheet, so hopefully it's true. So if you need the volume of a cylinder or something like that, and you don't remember how to do that, it is in your textbook as well there. As well, there are the summary pages for everything that we've done in this unit. So I think I attached those in your booklet. So keep in mind you can represent rates in similar ways. So write them with the same unit so the second terms have the same value, or the second terms equal to 1. You can graph the relationship looking at the slope. The slope of the line segment represents a rate of change that is a unit rate. So you can solve rate problems in multiple ways. You can convert from one form to another. Lots of different things that it's talking about, but these tips might, oh, on to the next page. So that was kind of from the first section. Then this is our linear scale factor and then bringing it into 2D shapes as well. So a scale factor between 0 and 1 is a reduction. A scale factor greater than 1 is an enlargement. A scale factor of exactly equal to 1 is just a straight up copy. So then that has our last couple formulas on here. So it still has that K, but again, now it will bring in, oh, our volume. So K cubed gets us our volume information. So that's that. That's that last lesson. Make sure you work through all those textbook questions and have a peek at the answers and ask me all the questions you need. There will be a review assignment for you to be working on prior to your quiz and unit test for the unit. So thanks so much, guys. Talk to you later.